Hi all, welcome back. As you know, the monsoon season has arrived early this time and it has been raining heavily in some parts of India. And I am also enjoying this monsoon season very much. Hope all of you are also enjoying it. And due to rains, our cricket matches are also not happening, which is not a good thing for me. However, our practice is still going on in the indoors. So now let's come back to our PYQ series. So today we are going to solve all the questions from complex numbers which came in different shifts of Jan 2025 attempt. In complex number we have total 10 questions out of which 6 are easily doable and 4 are moderate which we are going to solve. And this difficulty level is basis my perception which may be different for others. So let's solve our first question. Here is our first question now. Our question says, let the curve, here we have our curve, z belongs to C, divide this region into two parts of area alpha and beta. Then mod of alpha minus beta equals 2. Now to solve this question, here we are going to use the standard approach. Substituting z is equal to x plus iota y. Now when we will put z is equal to x plus iota y in the first curve, we will get x minus y plus iota x plus y. And when we will put z conjugate x minus iota y multiplied by 1 minus iota, it will be plus x minus y minus iota x plus y is equal to 4. Now iota x plus y and iota x plus y will get cancelled. So from here we will get x minus y is equal to 2. And from the other part we will get x minus 3 square plus y square is equal to 1. Please wait a minute. Now let's plot the graph of this circle. So here is our circle and the center of circle is at 3, 0. Now let's find point of intersection of these two curves. So we will get x minus 3 square plus x minus 2 square is equal to 1. 2x square, 6 plus 4 minus 10x and plus 13 is equal to 1. We will get x square minus 5x plus 6 is equal to 0. So x is equal to 2, 3. So let's say that this is our line. So this point will be 2, 0 and this point will be 3, 1. So here we will get a right angle triangle, or we can say that this part is a quarter of a circle. So from here our area of shaded region, this is our, let's say, shaded region S, and this is our unshaded region. Area of shaded region is equal to area of quarter of a circle, which is pi into r square. R is 1. So pi by 4 minus area of this right angle triangle. So area of this right angle triangle is 1 upon 2 into 1 into 1. So minus 1 upon 2. Now let's find area of unshaded region. So this is equal to area of circle minus area of shaded region. Pi minus area of shaded region. So this is equal to 3 pi by 4 plus 1 by 2. Now let's say that area of shaded region is alpha and this is equal to beta. Now it may be vice versa because in the question we have no condition for alpha and beta, but it don't matters which is alpha or beta, our answer will be same. So here modulus of alpha minus beta is equal to pi by 2 plus 1. So from here our option A is correct and we can see that our answer is correct. So here is our next question now. Our question says the number of complex numbers z satisfying these two equations is. Now here again we are going to use the same method. We are going to say z is equal to x plus iota y. So if z is equal to x plus iota y, now let's look at the second equation. Let's cross multiply it. We will get mod of z square plus z conjugate square divided by z into z conjugate. Now z into z conjugate is modulus of z whole square. So this will be mod of z square plus z conjugate square is equal to 1. From here we will get mod of x square minus y square plus 2ixy plus x square minus y square minus 2ixy is equal to 1. Now 2 iota xy will get cancelled. From here we will get x square minus y square is equal to half or minus half. When we will put z is equal to x plus iota y and mod of z is equal to 1, we will get x square plus y square is equal to 1. Now let's say this is our graph when x square minus y square is equal to 1 upon 2 x square minus y square. So our circle will be, this is our circle, and x square minus y square is equal to half will be of this type. So from here we will get 4 roots. This is x square minus y square is equal to half. And from the other graph, let's say here is our circle again. From the other one, x square minus y square is equal to minus half. We will again get 4 roots. So from here, our number of solutions is equal to 8. 1, 2, 3, 4, 1, 2, 3, 4, 8. So from here, our option B is correct. And here is our solution and we can see that our answer is correct. So here is our next question now. Our question says that here is our equation for all z belongs to C be the equation of a circle with center at C if the area of the triangle whose vertices are the points 0, 0, C and alpha, 0 is 11 square units, then alpha square equals to. So here in this question, we again need to say z is equal to x plus iota y. So we will get, let's cross multiply this, we will get mod of 3 times z conjugate minus iota is equal to 2z conjugate plus iota. So from here we will get 3 times, let's take square both sides, this will be 3 square mod square square. So this will be 9 times x square plus y plus 1 square y plus 1 square, yes, plus this is equal to 2x square plus 1 minus 2y square. From here we will get 5x square plus 5y square, 18 plus 4 plus 22y is equal to, plus 22y plus 9 plus 8 is equal to 0. Now from here our center C will be minus 11 upon 5 comma 0, 22 upon 2 upon 5. So let's say here is our coordinate axis. This will be origin 0, 0. This point is, let's say, minus 11 upon 5, 0. Sorry, this is 0, minus 11 upon 5. Here we have y, 22y. 0, minus 11 upon 5. And here also, well, this is on my axis, sorry. 0, minus 11 upon 5. And this point is alpha, 0 according to the question. So here we can see we have a right angle triangle and area of this triangle is equal to 1 upon 2 into mod of minus 11 upon 5 into mod of alpha is equal to 10. So it is equal to 11. From here we will get mod of alpha is equal to 10. Alpha square is equal to 100. So from here our option B is correct. And here is our solution and we can see that our answer is correct. Here is our next question now. Our question says let z1, z2 and z3 be 3 complex numbers on this circle with argument this, and this. If this expression is equal to this expression where alpha, beta belongs to z, then the value of alpha square plus beta square is. So here in this question, first of all, we are going to write z1 z1 is as mod of 1 e raised to power iota. Argument of z1 is minus pi by 4. Minus pi by 4. And similarly we will write z2 is equal to 1 e raised to power iota 0. z3 is equal to mod of 1 e raised to power iota pi by 4. Now this is equal to 1 upon root 2 minus iota upon root 2. This is equal to 1, and this is equal to cos pi by 4 1 upon root 2 plus iota sin pi by 4. So iota upon root 2. Now we will find z1, z2 bar. So this is equal to 1 minus iota upon root 2. And z2, z3 bar is equal to 1 minus iota upon root 2. And z3, z1 bar is equal to 1 upon root 2 plus iota upon root 2 whole square. So 1 upon 2 minus 1 upon 2 and plus 2 times iota upon 2. So plus iota, this is equal to iota. So our required expression mod of z1, z2 bar plus z2, z3 bar plus z3, z1 bar whole square is equal to mod of, now sum of these two will be root 2 times 1 minus iota, so root 2 plus with iota we will get 1 minus root 2. 1 minus root 2, yes, whole square. Please wait a minute. Here our conjugate is writing. Let me write this last term again. Plus z3, z1 bar. Yes, now it's correct. Now this mod whole square is equal to 2 plus is equal to root 2 square, 2 plus 1 minus root 2 square, 1 plus 2 minus 2 root 2 is equal to 5 minus 2, 5 minus 2 root 2. So from here our alpha is equal to 5 and beta is equal to minus 2. Alpha is equal to 5, beta is equal to minus 2. So alpha square plus beta square is equal to 29. From here our option B is correct. And here is our solution and we can see that our answer is correct. Here is our next question now. Our question says if alpha plus iota beta plus gamma plus iota delta are the roots of this quadratic equation where iota is equal to under root of minus 1, then value of this expression is equal to So here in this question, we will find the roots of this quadratic equation, which is very easy. So x is equal to minus b. So 3 minus 2 iota plus minus under root of b square minus 4ac. So this will be plus 4 2 iota minus 2 divided by 2a, which is 2. So this is equal to 3 minus 2 iota plus minus under root of 9 minus 4, 9 minus 4 minus 8, and minus 12 iota plus 8 iota divided by 2. So this is equal to 3 minus 2 iota plus minus under root of minus 3 minus 4 iota divided by 2. So this is equal to 3 minus 2 iota plus minus under root of 1 square plus 2 iota square. From this, from here we will get minus 3 minus 2 times 1 into 2 iota. From here we will get minus 4 iota divided by 2. Now this is equal to 3 minus 2 iota plus minus. Now this is a whole square of 1 minus 2 iota. So it will get outside the root. 1 minus 2 iota divided by 2. So this is equal to 2 comma 2 minus 2 iota, and with minus we will get 1 plus 0 iota. So from here our alpha is equal to 2, beta is equal to minus 2, alpha is equal to 2, beta is equal to minus 2, gamma is equal to 1, delta is equal to 0. So alpha, gamma plus beta, delta is equal to 2. From here our option D is correct, and here is our solution, and we can see that our answer is correct. Here is our next question now. Our question says, here we have a circle and this is also a circle. Z1 comma Z2 belongs to C, then minimum value of mod of Z1 minus Z2. So let's say this is C1, this is circle 2. Now we have two circles, 1 and 2. So let's say center of this circle is C1 and center of this circle is C2, and this is the distance between the center. Now minimum distance between a point lying on this circle and point lying on this circle is C1 minus C2 minus the radius of two circles. So here we will get the minimum distance. So let's find C1. C1 will be 8, 2, and C2 will be 2, minus 6. R1 is equal to 1, R2 is equal to 2. C1, distance between C1 and C2 is equal to under root of 36 plus 64 is equal to 10. So mod of z1 minus z2 min is equal to c1 c2 minus r1 minus r2 is equal to 10 minus 1 minus 2 is equal to 7. From here, our option D is correct. And here is our solution, and we can see that our answer is correct. Now here is our next question. Our question says, let alpha comma beta be the roots of this quadratic equation with imaginary part of alpha is less than imaginary part of beta. Pn is equal to alpha n minus beta n, and here we have P3, P4 and P5, P6. Then we have to find the value of this expression. So here in this question we are going to use Newton's identity, and then we will substitute the given value. So first we will say P6 is equal to AP5 plus BP3. So from here we will get 45. Root 7 iota will get cancelled. 45 is equal to 11a is equal to 11a. This is 4, sorry. 11a minus 3b. Now we are going to do for 5. P5 is equal to AP4 plus BP3. From here we will get 11 is equal to minus 3a minus 5b. Now in the first equation we are going to multiply by 3. In the second equation we are going to multiply by 11 and then add. We will get 45 times 3. This will be 135 and 121. So this will be 256 is equal to 8 term will get cancelled, and we will get 55 plus 9, so minus 64b. 64 times 4 is 256. b is equal to minus 4. From here our a is equal to, if b is minus 4, from the second equation we will get 20. 20 minus 11, 9 is equal to 3. Now a is equal to 3. Our alpha plus beta is equal to a, which is equal to 3, and alpha beta, which is equal to minus of b, is equal to 4. Now mod of alpha 4 plus beta 4 is equal to mod of, now we can write alpha 4 plus beta 4 as alpha square plus beta square whole square. Again we can write alpha square plus beta square as alpha plus beta whole square minus 2 alpha beta. Now from this we will get alpha square plus beta square whole square minus 2 alpha square beta square. So So this is equal to mod of alpha plus beta whole square minus 2 alpha beta. So 1 square minus 2 times 16, 32. So this is equal to 31. From here our answer is equal to 31. And here we can see that our solution was correct. Here is our next question now. Our question says if alpha and beta are roots of this equation where iota is root of -1, then we have to find the value of this expression is equal to solve this question, we will manipulate the above quadratic equation. Now here I see one thing common. If we will take alpha 15 common from alpha and alpha terms, we will get alpha 4 up plus 1 upon alpha 4. Same for the beta and beta. So using this quadratic equation, we are going to try to find alpha 4 plus 1 upon alpha 4. So from the quadratic equation, we will get 2 times z minus iota upon z is equal to 3. We will put z as alpha and this will be alpha minus iota upon alpha is equal to 3 by 2. We will take square both sides. We will get alpha square minus 1 upon alpha square minus 2i. So this is equal to 3 upon 2 plus 3 upon 2 plus 2i. Sorry, 9 upon 16. 9 upon 4. 9 upon 4 it will be. Plus 2i. Now this will be, again we will take square both sides. We will get alpha 4 plus 1 upon alpha 4 minus 2. This time we will take it to the right hand side. 81 upon 16 minus 4 plus 2 minus 4 plus 2 and plus 9 iota. So this is equal to 81 minus 32. From here we will get 49 upon 16 plus 9 iota alpha 4 plus 1 upon alpha 4. Now we have derived this relation from this quadratic equation, and beta also satisfies this quadratic equation. So this relation will be true for beta also. Plus 9 iota. Let me check 9 iota. Yes. Plus 9 iota. Now alpha 19 plus beta 19 plus alpha 11 plus beta 11 divided by alpha 15 plus beta 15 is equal to, now we will compare, we will take alpha raised to power 15 common from the alpha terms. We will get alpha 4 plus 1 upon alpha 4. Same for beta divided by alpha 15 plus beta 15. Now these two terms are same, so we will take common alpha 15 plus beta 15, numerator denominator will get cancelled. This is equal to alpha 4 plus 1 upon alpha 4 is equal to 49 upon 16 plus 9 iota. So our answer is equal to 16 times real part of this expression, 49 upon 16, into imaginary part of this expression, which is 9, into 9. 16 will get cancelled. 49 into 9 is 1, 8, 4, 4, 1. So from here, our option A is correct. And here is our solution, and we can see that our answer is correct. Here is our next question now. Our question says, O be the origin, the point A is this, point B is this, B such that here is our relation. And here we have relation between argument of Z1 and Z2. Then which of the following is correct? So here in this question, first of all, we are going to plot a triangle. This is our triangle OAB, and this angle will be pi by 6. Now distance between O and A, point A be this. So OA is equal to root 11 and OB is equal to root 11 by 3. So from here, our AB is equal to our AB will be OA square plus OB square minus 2 times OA dot OB cos of angle between OA and OB, pi by 6. So AB square is equal to this. So this is equal to 11 plus 11 by 3 minus 2 times 11 into root 11 into root 11 by 3 into root 3 by 2. These two will get cancelled, these two will get cancelled, and 11 will get cancelled. So AB is equal to root 11 by 3. From here, OB is equal to AB. OB is equal to AB. So this angle will also be pi by 6. If these two are pi by 6, this angle will be pi minus pi by 3, 2 pi by 3. Now from here we can say that triangle OAP is obtuse because at B we have 2 pi by 3. Obtuse angle isosceles triangle. So from here, our option B is correct. And here is our solution, and we can see that our answer is correct. Here is our next question now. Our question says, let integers a comma b mean this such that a plus b is not equal to 0. The number of all possible ordered pairs a comma b for which this is satisfied and z satisfies this. Z belongs to C, where omega and omega square are the roots of this equation, is equal to. Now here in this question we need to find the number of possible ordered pairs. So let's say here is a determinant. Now In the row 1, we are going to add all the rows. We will get determinant of z plus 1 plus omega square, 1 plus omega square is equal to 0. Put omega in this equation. We will get z, and here also z, or we will take z common. We will get 1 omega square 1 z plus omega square 1 1 z plus omega is equal to 1. Now here we are going to subtract column 2 by column 1 and column 3 by column 1. So we will get z times determinant of 1 omega square 0 z plus omega square minus omega 1 minus omega square, and other will be 0 1 minus omega z plus omega minus omega square is equal to 1. From here we will get z into 1 times this minus this into this. This will be z square plus z omega minus z omega square z omega square plus omega cube and minus omega 4 with minus omega minus z omega minus omega square plus omega cube minus omega plus omega cube, and these two multiplied in minus, this will be minus 1 plus omega square omega minus omega cube is equal to 1. Now here a lot of terms are getting cancelled out. Z omega square and z omega square will get cancelled. Minus omega cube. Now our omega 4 is omega. So these two will get cancelled out. Plus omega square minus omega square. Omega cube is 1. 1 minus 1 will be 0. Minus z omega plus z omega. So from here all the terms cancelled out, leaving z square. So z cube is equal to 1. Z is equal to 1 comma omega square. Now we will take z is equal to 1 and put it here. We will get mod of 1 minus a is equal to mod of 1 plus b. Then from here, when we will open it in positive, a plus b is equal to 0 and other will be a minus 1. So a minus b is equal to 2. So a plus b is equal to 0 will get rejected, because in the question there is given b says that a plus b is not equal to 0. So from here our pairs a comma b will be -3 then 1. minus 1. Minus 1 plus 3 will be 2. 0, comma, minus 2. Yes. 2, comma, 0. Yes. 3, comma, 1. Yes. Now for the other, omega minus a is equal to mod of omega plus b. We will get modulus of. Now our omega is equal to minus 1 plus root 3 iota by 2. So minus 1 upon 2 minus a plus root 3 iota by 2. Root 3 by 2 iota is equal to modulus of minus 1 upon 2 plus b plus root 3 by 2 iota. We will take square both sides. We will get now 3 by 4 when we will take root 3 by 2 whole square, and from the right side both will get cancelled. We will get 1 upon 4 plus a square. 1 upon 4 plus a square plus a is equal to 1 upon 4 plus b square minus b. From here we will get from here we will get 1 upon 4 will get cancelled. A square plus a minus b square minus b is equal to 0. So a minus b and a minus b plus 1. Let me check it. A square minus ab plus a minus ba, ab and minus ab and minus b, a. This will be a plus b. A square minus ab plus a. ba minus b square plus b, yes. This is equal to 0. This will be rejected. This is accepted. So our a minus b is equal to minus 1. A minus b is equal to minus 1. From here our pairs a comma b will be minus 3 comma minus 3 comma minus 2 and minus 1 comma 0 minus 1 comma 0, yes. 2 comma 2 comma plus it will be not 2, 1 comma 2 and minus 2 comma minus 1 minus 2 comma minus 1 and 0 comma 1 1 2 3 4 and I think I've written all the cases. 2 comma 3 is left. So from here let's count the cases. 1 2 3 4 5 6 7 8 9 10. From here our answer is equal to 10. This question is moderate and also a little bit lengthy. So from here we can see that our answer is correct. So hope you found this video helpful. Thank you for watching.